Hello, welcome to the wonderful world of random sequencing. Also, I have another channel called Sequencing Random Numbers, and we're going to be dealing with Superlotto Plus. So, to begin with, I'd like to introduce some concepts within the language of what is random sequencing. Uh, Now, this is my language, basically. I don't think you'll find it on the web. So, but there are concepts that you'll be familiar with now. The binary numbers. Now, binary numbers could be sequenced in, in Super Lotto, roulette, and other forms of lottery. Now, for instance, binary numbers like this one right here, as you can see right there, that could be 11. In other words, 1 is 11. That could be a binary number. Binary decimal numbers. Now this is a binary decimal number right here. In other words, 11 and 41 linked together like that. They form a binary decimal number. The 111 is 7 in binary notation. Linked to this number right here is 47. So if you go over here, notice how you have that 4, 7 right here. See, now uh, these numbers here. Now these numbers here could be sequenced. They're calendar dates and they're ticket numbers, and now they have a direct relationship with the synchronicity of what is happening within the day of the lotto spins. The and so the calendar dates are linked to these sequences right here. See, in other words, this 14. Now notice this 14 right here. See, now that could play out over here, but what it does is that it plays itself in a reverse fashion. In other words, it creates a 41. And part is due to the fact that it's also playing out this 47. And when it does that, now you got to think that if it does play out a 47, right? Because you have a 41 already formed, uh, then it's going to play an 11. Now, when it does that, it creates 47 this way. You see, the 111 is 7 in binary notation, and linked to a 4, that's 47. So that's something that you should be familiar with. Um, Now, another thing is that notice how it played out 1131. Now, that is 37. In other words, the 111 in binary notation is equal to 7. And then linked to a 3, that makes 37. See right there? So 37 plus 37 is equal to 74. So this number here can play itself out in the sequence as 47 and 74. Like what it did here is that it played itself as 37, 37. So what it did is created the first 37 here. See that? So if you were to assume that, right, because you know that it's going to be making a 4111 sequence, which forms a 47, that it could also be playing out a 74 sequence, which is 37 plus 37, and it began by forming this sequence right here. This sequence here is 37. So if you were to assume that, you would have two numbers right there right off the bat. I'd like to talk about the 31 here. Now the 31 carries a statement 3 ones, which is 111. Now this could actually sequence to a 7. 111 in binary notation is 7. But if you go over here, notice how you do have a 31 here, right? And this 31 hasn't been played out here. It hasn't been played out here. But notice that it did play out here. Now, and you have a 31 right here too. So this number has to be played out. And if it didn't happen here or here, it'll probably happen right here, see? Because it's sort of saying, it's stating itself right here. This is 3 ones, which is 111, right? And then this right here is a bridge number. It allows this number here to sequence here. And you already have this ticket number right here, so there's a high probability that it will play out a 31. So that's something that this is what you call frequency of occurrence. When you see a frequency like this 31 and this 31, and you know that it hasn't been played out, it'd be a good assumption to expect it on this particular sequence because it has to be played out. I'd like to talk about this sequence here, the 38. Now, whenever you get a 38, it could sequence to 24, so that's something that you should probably be familiar with because 3 times 8 is 24, right? And so, if you notice how you have the 42, now you could get a reverse sequence with this 42. In other words, this could translate as 24, so that's kind of a reverse sequence. So there's kind of a theme that's kind of being played out. One is the reverse sequence, right? And another one is that the 3 times 8 is equal to 24. So there's a good probability that that 24 is going to be played out right there. I'd also like to mention this sequence here. Now, this sequence right here plays out a theme, and that theme is 46. And the way it makes 46 is that if there are two cells, right, 22 and 42, if you add all the twos, that's 6. Linked to a 4, that's 46. You see, 46. So it's very possible that it's going to create a 46. Now notice how you do have a 6 right there, right? Now you could assume that it's going to probably play out a 4. And in that case, it would play out, 46. So this is a red flag that it could play out a 46. And then the moment you see that 6 there right here, right, played out, then you know that it probably will play out a 4 there. Another thing is that this 24, the 24 carries the statement 2 fours. What is 2 fours? 4 4. So if you have a 24 there and you have a 4 right there, there's good possibility that it'll create another 4, because the 24 carries the statement 2 fours. You see. I'd like to talk about the 6 here. Now notice how you are in this environment. This is the end of the trail of the 12s here, the 12th month, right? And so it could play itself out. In other words, it could play out a 6 is equal to 6. And so actually that's what happened right here. So in other words, 6 plus 6 is equal to 12. So this is like a statement of equality. The 1 1 is in binary notation. This is the equal symbol, like in mathematics, equals, you see. So if you have a 12, and this happens to be the end of the trail of the 12s, right? And so if it played out a 6 here, and so a 6 is the theme that's going to equal 12, right? So you could assume another 6 here, right? But what it did is it created the 11. Now the 11 is the statement of equality. So in other words, it's going to link another 6. So in essence, this is a 6, and then you have the equal statement, and then it connects this other 6. So now what you have is 6, 6 is equal to 12. So this is the 12. Now, and another thing is that if this is an important theme to be played out. So it's quite possible that if once you saw the equal statement, and you know that it's going to create a 6, then you could assume that that this is a big theme that's going to be played out. In other words, it could create another 6 of a different form. And one way of doing that is by doing the 2022 sequence. The 2022 sequence, if you were to count all the 2s, you get 2, 2, 2, that's 6, and then linked to 0. So basically you have 6, 0, or 0, 6, which is equal to 6, right? So in other words, this number here could sequence to a 6, and we actually did it right there. So this is a relationship that you should understand. Now this is, again, this is equal to a 6. Now these numbers here could I've already mentioned that they could play themselves out. In other words, this 21 and this 12 could play itself out, and because notice how you do have a 1 there, right? And so all you need to play this out is to form a 2 right there. Now that could either be 12 or 21. Now, if it's 12, it's equal to 6 plus 6, right? And that it could play itself that way, but it could also play itself as 21. Now, the 21 carries the statements two ones. Two ones. In other words, two ones is 1 1. So if this is two ones, right, that's equal to 1 1, which is 11. So that's how you translate that sequence. So it's playing itself as a 12, and it's also playing itself as 21. I'd like to talk about the 48. 48 sequence is equal to 96 and 69 in reverse sequence right here. Now, whenever you get a 48 sequence, that'll translate to a 96 or 69 sequence. Now, if you look over here, now notice how you got these two digits here and this one right here. The digits to the right side, they have sequential potential. In other words, if this 48 links to this 48 right here, you see right there, that makes 48 plus 48, and that's equal to 96. And it could sequence as a 9-6 or a 6-9. Now notice how that, like right here, you have 48, and then over here you have 48, then it's sequenced to a 6-9. You see that? I'd like to talk about the 2. Now the 2 here could have a factorial statement. In other words, notice how it has the 2 and then the 30 right there. Now that could state two 30s. And as you can see right here, it created another 30. Now, the reason why it created another 32 is also, a 30, is because of this ticket number. This is number 30. So this could sequence right here. And over here you have a statement of two 30s. Now, two 30s is 30, 30. 30 plus 30 is equal to 60. So what happens usually is that it forms a 60. Now, what it does is like it'll sequence to a number that has a 0, and then that 0 will sequence to a number that has a 6, and it'll create a 6 0. See that? So basically it's 30 30, and then it'll have two cells that'll make 60. In other words, on the right hand side digits, here's your 6 and here's your 0, and it makes like a 60 right there. I'd like to talk about the theme of calendar dates and ticket numbers here. Now, whenever you reach the end of the trail of this month, in other words, this is December, right? The 12th. It's the end. That's the last day of these spins, right? And so this sequence becomes very important. And so what you need to do is you need to translate what is 28 equals to and what is 29 equal to. And it's quite possible that these two sequences are going to have two numbers that equal each other. For instance, now here's 28, right? So we're gonna look at 28. The 28 carries the statement 8 8, and 8 plus 8 is equal to 16. So now you know that the 16 is a possible sequence. Now the 29, this is this number, right? 29. Now the 29 carries the statement 2 9s. What is 2 9s? 9 9. 9 plus 9 is equal to 18. So now you know that the 16 and the 18 can sequence. Now if you go over here, like here's the sequence, right? And so what in other words, it didn't get played out here, right? Because this number here, the 1 1, that forms a statement of, in other words, it's a bridge number. The bridge numbers are 11, 13, and 14. So it allows this sequence to go on to this position right here, right, 11, and then play itself out right here. So here's your 16, and here's your 18. And this number right here was very important. And so knowing that relationship and knowing that this is a bridge number, right, and this is also a bridge number too, right? And so it could play itself out right here. So in other words, you would play out a 16 and 18. Okay, I'd like to talk about the 223 sequence. Now, I already mentioned that the 2 has the factorial statement. In other words, I already told you how it linked to this 30 right here, see? But it also could link to this 23. Now, 223s is equal to 23 plus 23 is equal to 46, right? So it's quite possible that it could form a 46. And as you can see right there you have a 6 there, right? So by putting a 4, you make 46. And these, it's very important that you consider the 2 as a factorial statement. Linked to that, link to the 23, sorry, that makes 23 is equal to 46. So there's your 46 right there, see? And it's a theme that got played out again right here. Uh, Also, for instance, the 46 plus 46 is equal to 92, right? And so one way that the 92 is represented is by the 29, and has a reverse sequence too. So that's something you might want to consider. So this, again, this is this playing itself as a factorial statement. Now this thing is another thing is that notice how you have the 211. Now the 211, this is a binary number. This is the 1 in binary notation is 3. So basically what you have, a theme. This is 23, right? And then what it does, because it's playing itself as a theme, it puts in 11 to equal 23. In other words, this 1 in binary notation is 3. So you got 23, and then this forms 23, and this equals 23. See? So you got 23, 23, and then it plays out a 23 right there. So that's pretty much it, and I hope you enjoyed these sequences. Again, it's a wonderful world of random sequencing. That's one channel. The other channel is sequencing random numbers, and we'll see you on the next Superlotto Plus.